Right, now let's discuss the first topic, the reservoir sedimentation. Let's head on to problem, or rather example 17.19. Right, so you have a reservoir with an area of 400 square kilometers. Right, so you're talking about just the reservoir or the impounded area, not the watershed. All right, don't be confused. You have a reservoir, and it also has an average depth of 24.8 meters. So from there, you can easily calculate the volume of your reservoir from these parameters. Another given is the inflow or water inflow to the reservoir from your river or from your watershed, and the average flow rate is 3,000 cubic meters per second. Now, note that water that you get into dams will always have a suspended sediment. All right, always happens. I mean, when you're talking about a watershed, watersheds always transport sediments. Now, going back, the concentration of the sediments from the inflow is 150 milligrams per liter, right? Now, one of the questions is estimate the rate at which the sediment is accumulating in the reservoir. So basically, how fast is the sediment accumulating in the reservoir? How fast is the sedimentation occurring? So you can express this in terms of volume per year, all right? Like this in the example. And then the other question is the rate at which the depth of the reservoir is decreasing due to sediment accumulation. So this is quite basic. You basically have to know the volume. So you start with the rate of the sediment accumulation and then divide it by the area of the reservoir. All right. And then finally, the last question is the how much. The third question is what is the average suspended sediment concentration of the water that is being released from the reservoir. So you have sediments that are entering the dam. Some of them are being retained or accumulated in the reservoir, while the rest are essentially just escaping or being released from the reservoir. So you just have to calculate for that. Alright, so this is the solution from the example. And yeah, you can read that later, but just to give you an overview, I'll just discuss the solution quickly. Right? So again, you can just, or rather, you're encouraged to just submit a spreadsheet solution for the exercises. Right? I know this is the finals week, and some of you might not even have the time to do this bonus exercise, or even just watch this exercise video. Anyway, so this is quite a crappy solution, but it works. I'll just be discussing it briefly. So I have here blocks of cells which just show the solution per step of the problem. Now the first step is to know the mass of the sediment that is inflowing into your reservoir. So mass of sediment, all you have to know is, right, so how much mass of sediment are we getting into the reservoir per year? Now all we have to do here is to multiply the inflow rate by the sediment concentration. Now to do that, so you're given the inflow rate, water inflow rate in cubic meters per second as per the textbook. You also right now all you have to do is convert this rate into cubic meters per year. So just multiply it by days, months, hours, right? So seconds to year, and you'll eventually get this number, which is 94 billion, 94.6 billion cubic meters per year. All right. So that is the total water inflow for a year. All right. Volume. That is the volume of water that's getting into the dam throughout in a period of 1 year. Now, you're given the sediment concentration, and I just converted the milligrams per liter into kilograms per cubic meter, right? Now, since we have similar units, cubic meter, to get the mass of sediment that's inflowing into your reservoir, you just multiply the concentration, the sediment concentration by the volume, water volume inflow, right? And you will get approximately, or rather, you will get 14.2 billion kilograms per year of sediment, which is a lot. Right now, let's park that value. Let's move on to the storage capacity or the volume of your reservoir. Right, so this is the total volume of your impounding reservoir. Basically, to know the volume, you just multiply the area by the average depth. It's that simple. You have an area, I convert it into square meters, right? I'm also given an average depth, which is in meters. Now, to get the volume of the reservoir, I just multiply the area by the depth, and I'm getting here 9.9 billion cubic meters. All right. Now again, let's park that value. Let's move on to the trap efficiency. As discussed in the lectures, trap efficiency is important because trap efficiency essentially tells us how much percent of our sediment inflow will be retained or accumulated. All right. So note that sediment going into the dam, right? Only a portion of it will accumulate in the dam, and another portion of it will outflow from the dam. Now, trap efficiency. So all we have to do here is to get the ratio of our storage capacity versus the inflow. All right, so we just need the storage capacity of the dam versus the inflow volume per year. So we have the storage capacity, which is 9.9 billion, and we have a value for the inflow volume per year, which is 94.6 billion. All right, and the ratio is approximately zero point 0.1. Right, so we head on to the chart of USBR, or the US Bureau of Reclamations. So this chart will help you uh, estimate or calculate the trap efficiency based on the size of your dam versus the annual inflow volume, which we did here. All right, so our ratio is point 0.104 or approximately zero point 0.1. And if you will be projecting that to the chart, so I used here a rectangular shape. So this is zero point 0.1. All right, this is the intersection with the curve. And if you read it here on the y-axis, I'm getting a value that's somewhere between 90 and 80. All right, so it's a little bit above the halfway point, so it's approximately 86 or 87%. All right, so that is the value of the trap efficiency, around 87% or 0.87. All right, so it means that 87% of the sediment that is entering the dam is actually being retained or accumulated. All right, so it means the dam is just gobbling up all the sediment or most of the sediment it receives at a rate of 87%. Right? Now, let's move on to the mass of sediment that is being retained or accumulated in the reservoir dam. So this is just equal to your trap efficiency times the mass of your sediment inflow. So as you will remember earlier, we calculated the mass of sediment inflow per year. All right, so we have a value of 14.2 billion kilograms of sediment per year. Now multiply that by your trap efficiency of 0.87, you get a value of 12.3 billion kilograms per year, right? So that's how much sediment is being retained or accumulated in your reservoir dam. Now, the problem is asking for a volume, but note that the exercise actually provided a bulk density for the accumulated sediment. So it says here that let's let's just assume that the accumulated sediment has a bulk density of 1,600 kilograms per cubic meter. So from the mass here, we can convert that into volume, right? So we just divide the mass, so we take the mass and divide it by the bulk density, which is 1,600 kilograms per cubic meter, and we get a number of 7.7 cubic meters per year. Okay, 7.7 million cubic meters per year of sediment. All right. So that's how much sediment you're getting per year in the dam. If you need to design the dead storage or inactive storage capacity of your dam, all you have to do is just multiply this value by the lifespan of your dam. All right. But note that it's actually not a straightforward calculation because as you increase sediment in your dam, you're actually decreasing your storage capacity. So over time, actually as your dam fills up with sediment, as your dam fills up with sediment, all right, your storage capacity decreases. So what happens here is that your ratio is actually decreasing over time. And when you have a decreasing ratio of storage capacity to your average inflow volume, it means that you are moving, your tap efficiency is moving to the left side of your chart. So through the years, the trap efficiency of your dam will actually be decreasing. All right, so it will be decreasing over time. So over time, your dam will be taking in less and less sediments. All right. So anyway, let's go back to the problem. So we answered the first question, which is how much volume is being retained in the dam per year. So that's 7.7 million cubic meters per year. Now the next problem is what is the rate of decrease in depth or height of the dam per year? So this is an easy question. All you have to do is to take the volume change per year and divide it by the area of your dam. All right. And what we are getting here is 0.019 meters per year or approximately 1.9 centimeters per year. So you have a big ass dam here. So despite the 7.7 cubic million cubic meters of sediment, you're only getting a change of almost 2 centimeters per year. All right. Now the last question is actually the easiest, which is the concentration of sediment being released. All right. Now note the problem here also had an assumption, which is uh, yeah. So the problem here, or the example here, they are telling us that you can assume that the average outflow rate of the reservoir is equal to the average inflow rate. All right. So the example here is telling us to assume that the inflow rate or the water inflow volume is just equal to the water outflow volume. Right. Now, now, so the steps here to get the concentration of your sediment outflow. So first we have to know how much sediment is actually being released by the dam. Right? So this is just an inverse of just have to get the inverse value, the right? So all you have to do is just take the remainder from your tap efficiency. So you just take 1 minus your tap efficiency. Alright, so that is 0.13 or 13%. Okay, so 13% is the proportion of sediments that is being released from the dam. So 13% multiplied by the mass of sediment inflow, alright, you will get 1.8 billion kilograms of sediment released per year. Alright? Now, since the volume of water outflow is just same as the inflow, so we have here a value of 94.6 billion cubic meters per year of water outflow. Now, to get the sediment concentration, all you have to do is just divide the sediment released by the volumifer outflow per year and just convert that quantity into milligrams per liter, right? So that concludes the part 1 of the bonus exercise. All right, in the next video I will be discussing the storage requirements of dams